All right, so let's now do a couple of different types of examples once we have learned about all the 6 basic trig functions. And so one of our example here, one type of example here is that we want to find or evaluate the exact value of the expression. And so the expression I have here is going to be 16 tangent square at pi over 3 minus 30 cotangent of pi over 3. So in this example, the idea now that we start bringing in, and it could be in some other example problem, that we have an expression where it involves tangent and cosine and sine, all of those. But so basically, this is still an evaluation, a basic evaluation problem, but it brings in more than one trig function in one expression. And so now for this problem, so the angle pi over 3, you can go ahead and look it up on your unit circle. And so pi over 3 on a unit circle. And by the way, so to get comfortable with the idea of tangent right here, then we can first writing it down as, so 16 as a coefficient, and tangent, and this symbol here means we square the tangent output. And so tangent square really means, and tangent is defined as sine over cosine. So tangent square of pi over 3 is defined as sine square of pi over 3 over a cosine square of pi over 3. And minus, so now that's how we worked out with tangent, and the whole idea is to get comfortable with evaluating tangent. After we've learned the definition of tangent after the lecture, and then minus, and here cotangent is defined as cosine over sine. And so after 30 here as a coefficient, we are going to produce a cosine of pi over 3 divided by sine of pi over 3. And so that's the easiest step to start out. Easy to remember. And so now the coefficient is still here, 16. So sine of pi over 3 is the value square root 3 over 2. But then here the problem says, the expression says sine square, so we need to square that sine value. So remind yourself, on the unit circle it say pi over 3 is having the sine value being square root 3 over 2. And now we're going to square that later. So I'm strictly following with the order of operations here. And then cosine of pi over 3 is positive 1/2. Now we're going to square that expression. And then moving on to the later expression, the next expression, here is 30 as a coefficient. Cosine of pi over 3 is a 1/2 I put on top of my fraction. And sine of pi over 3 is the square root 3 over 2 I put at the denominator of my fraction. And so my next step, I'm calculating out, so there are 16 square root 3 over 2, all square is the same as now a 3/4 in the numerator. And then at the denominator here, 1/2 all square is a 1/4. And I use parentheses very extensively here. And minus, here's 30. And here we're going to start working out a fraction here. We got one fraction divided by another fraction. So that's going to be 1/2. And I'm multiplying by the reciprocal. So times 2 over square root 3. And so now 16 times, so back to my expression in a first term here, then I have 16 times, now it's going to be similarly with the other term, 3/4 times 4 over 1 minus 30 over 1/2 times 2 over square root 3. Some cancellation can happen, and now we're ending up with a lot more simplified expression here, we have 16, and I'm doing this here completely without the calculation for now, without the calculator. So 3 minus 30 times 1 over square root of 3. And so that now reduces down to 16 times 3 is 48, and minus 30 divided by square root of 30. And so even though not being written in the instruction of the problem, but the intention of these problems here is to be able to calculate and evaluate without using the calculator. And you will see what I mean in the following steps right here. But so my first term here, and these two terms currently are not really like terms. So here we're looking at 48 minus, but 30, we can go back to 30 and think of that as a 3 times 10 over, and I should have realized that I made an extra 0 here that we don't need. But so here it's divided by square root of 3. So square root of 3 will cancel with 3 right here and leaves behind a 10 times square root of 3. So this is the type of expression that this example is looking for. We don't need to use a calculator to get the decimal expression of this. And so without using a calculator, and the intention here is that the problem doesn't require you to use the calculator to pull out a decimal expression of this, but rather just look for a way how you can simplify involving rationalizing the denominator and turn that into a final simplified expression right there. And that's also clearly back into the problem. It said in the beginning that we just need to find the exact value of the expression. All right, and in another example of the same type, let's say we want to find or evaluate the exact value of the expression. And the expression I'm about to write down here, let's say we have 8 times secant of pi over 3 plus 30 times sine square of pi over 3. And so once again, the entire purpose of these examples, you can see that it's intended to create an expression that has a mix of those trig functions that we've learned, including the new ones that we've just learned. And so to work this out, secant in the first term is famously defined as 1 over, so here I'm looking at 8 separately, times 1 over cosine of pi over 3 plus 30 times this little square here is indicating that we really are looking for sine of pi over 3, then square. And so now it's going to become clear for the next step here. And so cosine of pi over 3, once again we have seen that through the unit circle, and 8 is my coefficient, so 1 over 1/2. And then for the next, and that's all we can do for the first term here. And the next term, 30 times sine of pi over 3 gives me a square root of 3 over 2, as you can look it up from the unit circle, or hopefully at this point when we're doing this example, everybody is fluent with doing the basic, those two value from the trig, from the sine and cosine function. But here we need to have a square there. And so now in my next step, I'm going to have the first term becomes, and I should have used the next line below so you can see the side by side how the problem being developed right here. But 8 is a coefficient, and here multiply with 1 over 1/2 is the same as 1 times a 2 over 1, okay, plus 30 is the coefficient of my next term. Square root of 3 over 2 all square now will become 3 over 4. right, and now the math is ready here for us. 8 times 2 in the first term becomes 16 plus, and then 30 times 3 over 4 gives us a 90 over 4. And we can make common denominator to make 64 plus 90 over 4. And that's now in my next step right here is going to be 154 over 4. And we can actually reduce this down to 77 over 2. And like I said again, there's no need to complete the final answer in a decimal form, so leave that in either a fraction or reduced square root form. And this is how we got the exact expression, the exact value of the expression. Alright, so in this type of example here, it's a big and quite comprehensive example actually, but it starts out by having a given sine of some angle theta, sine value, sine of theta equals 4/7, and it wants us, and also provided that theta is an angle in quadrant 3. Let's find the value of the other trig functions. And so what does this problem mean by finding the value of the other trig function? The other trig functions here, it means, so the problem only gives the value of sine of theta being 4/7. But remember, at this point we have learned there are cosine of theta, there are tangent, there are cotangent, the secant theta, and there are cosecant of theta. So in trigonometry there are always 6 fundamental functions of trigonometry, and once you have one given, then we are responsible to find the other 5. And so that's our aim right here, one by one. All right, so let me quickly delete this, clear out this list right here, and we're going to start going through them one by one. And so we actually have seen this similar examples in some of the past example I've done in other lectures. But so the Pythagorean theorem, the Pythagorean the identity famously says sine square of theta plus cosine square of theta equals 1. And that is now, we can start using that sine value given previously here. So sine square of theta plus cosine square of theta equals 1, but now we can start substituting sine of theta equals 4/7 into the place of, in place of the sine theta. And so that produces 4/7 r square plus cosine square of theta equals 1. And then as I'm starting with my first step right here, you can see my intention here is that I'm intending to find, we're here actually to find, we're going this route to find the value of cosine theta. Now keep in mind, the entire example here is not aiming at looking for the angle, the value of the angle. We're looking for the value of the other trig functions. And so to keep that in mind, that this is actually our goal for this current step right here. And so now I am going to subtract 4/7 square to the other side. And by the way, 4/7 square is a 16/49. And so in my next step, it's leading down to cosine square of theta must equals to 1 minus 16/49, because this is 4/7 r squared. And so here, and that 1 minus 16/49 is the same as 33/49. All right, and so here and now we are going to solve for the value of cosine by taking the square root of both sides, cosine of theta, equals, and don't forget, plus and minus square root of 33 over 49, which equals to plus and minus square root of 33 in the numerator over 7. And now we're going to have to rely on the quadrant information to find out which one is the correct sign of our cosine value. And so since theta is in quadrant 3, so let's put in that reasoning right here. Theta is in quadrant 3, and quadrant 3, remind yourself, quadrant 3 is down here. So any value down here has a negative value for x and negative value for y. And so in that way, being in quadrant 3 for theta, we are to select that choice. We are going to make our decision of using the correct answer for cosine theta. It would have to be negative square root of 33 over 7. And that is how we found the first other trig function. So we started out having, so once again, we started out having sine value, and now we came down to finding out what cosine value is. And we're still not done. So once we found cosine, then immediately tangent of theta equals sine of theta over cosine of theta. So this example, in the way how I see it, it is also a good reminder for everybody about how each of these functions is being defined. So now taking cosine of theta, the value of cosine theta we previously found in the earlier step. So here we're looking at putting negative square root 33 over 7 in the denominator and putting 4/7 in the numerator. And so that becomes 4/7 times negative 7 over square root 33. And so now the answer, after cancellation, comes down to negative 4 over square root 33. But then don't forget to rationalize the denominator, as a lot of assessments, a lot of problem from different places going to be asking your skill to rationalize the denominator. So here we're looking at multiplying numerator and denominator by square root 33, and that brings it down to, so that takes it to negative 4 square root 33 and divided by 33 in the denominator. So we've now found a value for tangent. Cotangent can also be found quite similarly. Cotangent started out as a definition, is being defined as cosine of theta over sine theta. And that gives me, so cosine theta is a negative square root 33 over 7 divided by 4/7. And that, once again, similar work with finding tangent earlier. Here we're going to end up with negative square root of 33 over 7 times 7 over 4. And canceling out the common factor 7 in the numerator and the denominator here, that reduces it down to negative square root of 33 over 4. And here we actually do not need to rationalize the denominator. So that is our final answer for cotangent of theta. Then it comes secant of theta. Starting out, secant is being defined as the reciprocal 1 over cosine of theta. And so now it's just now simply a matter of substituting in the value of cosine theta that we found very early in the problem. And so negative square root 33 over 7 that we put in the denominator allowed me to rewrite my negative square root 33 over 7. So here, negative square root 33 over 7. And that there is reducing down to a negative 7 over square root 33. And so that here we need to rationalize the denominator, since the denominator here is an irrational expression, is a number inside a square root, an irreducible value inside a square root. So we need to rationalize that denominator. So here I'm going to have negative 7 multiplied with square root 33 divided by square root 33 multiplied with square root 33. And that's just a reminder of how we rationalizing a denominator. So that here becomes negative 7 square root 33 over 33. And that is our answer for secant of theta. Last one in this example, cosecant theta. And once again, starting out, cosecant of theta is defined to be the reciprocal 1 over sine theta. And so we don't even need to rely on the value of cosine that we found previously. So here just simply 1 over sine theta. So your sine theta was given here, so it's 1 over 4 over 7. And that brings it down to 7 over 4, and we're done.